series to represent f of x is equal to x minus x square in x greater than minus 1 less than plus 1. So solution. So the given function f of x is equal to x minus x square. So in the interval what here, minus 1 to plus 1. So now, so first we'll check it, the value of L. So here I can say that, so 2L is equal to upper value minus lower value. Lower value is minus. So upper value minus lower value, upper value minus lower value. So 1 minus of minus 1. So which is nothing but 2L is equal to 1 minus of minus is plus 1, which is nothing but 2. So which implies the value of L is 1. So once we get this, now we'll think of even and odd. So f of x, they have given what here, x minus x square in the interval minus 1 to 1. So therefore, so here what we have to do here, replace x by what here, minus x. So replace x by minus x. So what happens if you replace x by minus x? So f of minus x is equal to minus x minus x whole square, which is nothing but minus x. This minus x whole square is what here, x square. So but this is not what here, if you take minus common also, so what will get here, x plus x square. So I can say that, so this is not equal to the function f of x. If f of minus x is what here, not equal to f of x, so at that time I can say that, because if it is coming plus f of x, it is even. If it is minus times f of x, odd. But this is not coming plus and as well as minus, because this function is some different only. So actual function what we have, x minus x square we supposed to get, but we getting something else here. So at that time we can say that f of minus x is not equal to f of x. So therefore I can say that f of x is equal to x minus x square is neither even nor odd. So it is neither even nor odd. So therefore the Fourier series is given by, so therefore the Fourier series is given by, the Fourier series is given by, the Fourier series is given by the Fourier series is given by f of x is equal to a naught by 2 plus summation n from 1 to infinity an into cos of n pi x upon L plus summation n from 1 to infinity bn into sine of n pi x upon L, where a naught is nothing but 1 upon L. So the limit is, they have given minus L to plus L, f of x, remember minus L to minus 1 to plus 1 they have given, so it will be minus L to plus L into dx. B a naught a n will be 1 upon L minus L to plus L f of x into cos of n pi x upon L into dx, and bn will be 1 upon L integration minus L to plus L f of x into sine of n pi x upon L into dx. So we'll find one by one a naught, a n, b n. So now first we'll take, but the value of L is 1, remember this, and we'll apply in all cases. So a naught will become out here 1 upon 1 integration minus 1 to plus 1 f of x, what we have here, so f of x is x minus x square into dx. So therefore on applying, so 1 upon 1 is 1, so integration of x is x square by 2 minus integration of x square is x cube by 3, limit from -1 to +1. So apply upper and lower limit. So if you apply upper limit, 1 square is 1 upon 2 minus 1 cube is again 1, so it will become 1 upon 3 upper limit minus lower limit -1. If you apply, so -1 square is again +1 only, so 1 upon 2 minus, so -1 cube is nothing but what here, -1 divided by 3. So on final simplification, a naught is equal to 1 by 2 minus 1 by 3 minus 1 by 2 minus minus plus into minus is minus 1 by 3. So plus 1 by 2 minus 1 by 2 cancels. So we'll get what's minus 1 by 3 minus 1 by 3 minus 1 by 3 will get minus 2 by 3. So therefore I can say that, so a naught value is minus 2 by 3. Now we'll go for an value. So an is nothing but 1 upon L, that is 1 upon 1 minus L to plus L, so it will become -1 to +1. So f of x is what here, it is x minus x square into cos of n pi x upon L, it will become n pi x into dx. So we'll apply Bernoulli's formula. This is u and this is v. We'll see now what happens. So on applying Bernoulli's rule, that is an is equal to, so x minus x square as it is. So integration of cos is what here, it is sine of n pi x upon n pi, formula minus differentiation of x minus x square is 1 minus 2x. So 1 upon n pi you carry, integration of sine is nothing but what here, minus cos of n pi x upon n pi. Next plus, so it will be on differentiation, so 0 minus 2, 1 upon n pi and minus 1 upon n pi carry, minus 1 upon n square pi square, cos n pi x is nothing but what here, integration sine of n pi x upon n pi, so -1 to +1. So if you replace one thing here, I will go directly. So if you replace x by 1, so sine n pi is what here, 0. If you apply -1, so sine of minus times is minus sine of n pi. So if you apply upper and both lower limit, so sine term will vanish first as well as the last term will vanish here directly, because if you apply both upper, so therefore, so our an will be left part with what here, this minus minus plus, so 1 minus 2x into cos of n pi x whole divided by n pi into n pi, it will become n square pi square, limit from -1 to +1. Or on applying upper and lower limit, we'll see what happens. So an is equal to, if you apply upper limit, so 1 minus, if a value of x is 1 means 1 minus 2, 1 minus 2 is -1, minus sign cos n pi, that is if x is equal to 1, cos n pi is nothing but -1 raised to 1 n. This is upper limit. So what I will do here, so 1 upon n square pi square I will take common, so this is minus sign, this is pi, okay. So I'll rewrite, so an is equal to 1 upon n square pi square will take common. So if you apply upper limit, 1 minus 2 into 1 is 1 minus 2, 1 minus 2 is nothing but minus sign, cos of n pi into 1 is cos n pi is -1 raised to n. Formula minus, if you apply lower limit, 1 minus 2 into minus 1, so it will become 1 minus of minus, it will become 1 plus 2. 1 plus 2 is nothing but what here, 3. Cos of n pi into minus 1 is nothing but cos of minus n pi. Cos of minus n pi is nothing but again cos n pi. Cos n pi is again what here, minus 1 raised to n. So we have applied upper and lower limit. So therefore, so a n is equal to, if you take minus 1 raised to n common, so minus 1 raised to n common divided by n square pi square as it is. So what left inside here, minus 1 minus 3, or I can say that minus 1 raised to n minus 1 minus 3 is nothing but minus 4 divided by n square pi square, or so pay attention, so a n is equal to this minus 4, I will write 4 into minus 1. This 4 into minus 1 is nothing but minus 4, and this minus 1 raised to n as it is divided by n square pi square, or I can say that, so 4 into minus 1, bases are same, minus 1 raised to 1 minus 1 raised to n, it will become 4 into minus 1 raised to n plus 1 divided by n square pi square. So this is the required value of what here, a n. So this is the required value of our a n. So similarly, we need to find the value of b n. So b n is nothing but 1 upon 1 integration minus 1 to plus 1. So x minus x square into sine of n pi x upon L, L is 1 into dx. So on applying Bernoulli's rule and upper and lower limit, I am writing the answer for Bn directly as, so here Bn on simplification, Bn will be 2 upon n pi into minus 1 raised to n plus 1. So you simplify and see this result, whether we'll get Bn as what here, 2 upon n pi into minus 1 raised to n plus 1. So therefore, finally, the required Fourier series is, f of x is equal to, so value of a naught, it is actually nothing but minus 2 upon 3. So 2 cancels, we'll get minus 1 upon 3 here, plus on simplification 4 upon pi square summation 1 to infinity minus 1 raised to n plus 1 divided by n square. I am rearranging and writing finally, you cross check, n pi x plus summation, so 2 upon pi will come here, 1 to infinity minus 1 raised to n plus 1 all divided by n into sine of n pi x. So this is the required Fourier series. So in this way you need to calculate and apply the formula. So you have to be careful while applying the formula, especially the values of a naught, a n, b n.